Well, hello everyone. Welcome back to the Tin Barn. I'm Pragmatic Lee, and today's project is going to be a reverse build of a 2-inch by 72-inch belt grinder. As you saw in that video, opening video, a little bit backwards there. And that's kind of what we're going to do. The project is finished. It's right here in front of me. I've been using it now for about a week and a half, kind of getting used to it. But I'm going to still take you through the entire build process from the ground up. I'm going to show you everything, basically everything on this. But we're going to do it a little bit different. I'm going to show you the finished product and introduce the parts that will be in each video, and then lead into the next video. This will be either a 4 or 5 part series. I'm not exactly sure right now. I've not finished putting all the pieces together. But in any case, let me turn the camera down here on the product. You can see that, and then I'll take the belt off and we'll proceed with the first machining part. Alright, briefly I'll go over the various parts that we're going to look at in machining in this next series of videos. The frame itself, structure, is built out of what's called hollow structural steel. Outside diameter 2 inches for the female pieces, 1 3/4 inches for the male pieces. We're going to look at putting that together. We'll look at the, this is the workbench portion of it here. I'll just set that out of the way for now. Well, we've got 3 rollers that we're going to look at building. The plating backing plate, which is behind this, the nuts, the T-bolts, T-handles, the drive pulley that's around here on the other side, the column, the pillow blocks, and the pillow block risers. So first off, let me take the belt off. The part we're going to look at in this video today are the rollers. There's 3 of these rollers, top, bottom, and let me raise the camera up just a little bit. This is the tracking roller up here. So we're going to go now and look at the manufacture or the machining of these 3 rollers. To make the rollers for this grinder, well, back up a step. I looked online, and the rollers for to make a 2x72 belt grinder are available on eBay. There's several different folks that sell them, and they range from about $95 to $110 for 3 2-inch rollers and a 4-inch drive roller. I'm going to use a much larger than 4-inch. I'll probably go 6 to 8 inch for the drive, just to get the RPMs up. So I'm going to attempt to make the rollers myself. Those on eBay are made from 6061 aluminum, and even some of them are molded plastic or cast plastic. So I'm going to try to make some out of some more of this mystery metal that you've seen me use in several projects lately. I made the pedestals for the vices out of it. I made the fly cutter recently out of this. I'm going to take a little longer piece than this. This is just a piece I had sitting up here on the workbench. But I'm going to take a longer piece of this, clean it up. It'll be a little bit less than 2 inches, but clean that up, get the rust off of it. Cut it in lengths about 2 1/4. I want it a little bit wider than the 2-inch sanding belt, grinding belt that'll be on there. And then I'm going to do that in a very quick video and fast forward you through the majority of that, because it's really all I'm doing is knocking that rust off, getting it down to a a good cylindrical diameter, and I'll carry it to the saw and cut it off, and then I'll put it back in the lathe and mill each ends, or each end to get it, or face each end to get it perpendicular to the sides. Okay, we're back from that little whirlwind video there, but didn't want to spend a whole lot of time on this project, just showing you how I cleaned the rust off of, and got that rough material down to a usable product. But we got, as you saw in that video, we got 3 nice pieces of this turned out now. I've got one of them in the 4-jaw chuck and got it indicated. I'm gonna drill this out to begin with. We need to bore the entire length of this to .990. So I'm going to start out and then step drill it to up to a 5/8. That's the largest bit I've got that's not, that is still less than 1 inch. So we'll get that in or get it started drilling. Alright, I got that first starter hole drilled through there. And I got a feeling my arm was getting in the way of the camera right much. So I'm going to change the camera position and continue drilling this out. Alright, that's got it drilled now. I'm going to put the boring bar on there, get set up for that. Alright, we have it bored out now, or drilled out now to 5/8 of an inch, which is 625 thousandths. I've got the boring bar in there now, and it's going to take, to get it out to 990, we've got approximately 365 thousandths to go. So I'll get the camera set up on this side when we get a little closer to the end. But now I'm going to bore this out, working that out about 20, 30, or 30, 40 thousandths at a time until I get it close. All right, we have about 10 more thousandths to go. I'm using, for this project, I'm using an R8 ZZ bearing. This bearing has a 1/2 inch inner bore and outside diameter of 1.125. The outside race, we need to leave, once we get this bored, to 990 thousandths. That is the diameter of the inside of the outer race on that. That's why we're going for the 990 here. So this should bring us to size, and of course I'll make a couple spring passes. Okay, that measures well within a couple thousandths on there. It's 994, but about 2 thousandths on each side. Now the outside bearing, outside race is 1.125. We want to leave an interference of about 1 thousandths, so we're going to bore a seat for the bearing. We're going to go a depth of 0.3125, the thickness of the bearing, and we'll bring this out to 1.124. All right, I'll set that up, and when I get a little closer, bring you back. All right, I got the carriage backed out of the way now. I think you can see what we're doing in here. We're creating a shoulder for this outside race to ride on, and we've only got about 4 more thousandths to go. And this entire project, this needs to be probably the most precise measurement on the whole project, is getting these bearings seated correctly. Now with the 1/1000th interference in there, this bearing should almost start in there, which it does. As a matter of fact, this one might take just a little bit of Loctite around it, but I think it'll be fine. Now we'll take our chamfering tool, clean those edges up just a little bit. Alright, I'm going to take this piece out of the forejaw, turn it around, do the same thing to the other end. Of course, it's bored all the way through now, so we just need to get the shoulder for the bearing to set on. Then I'll do the same thing for the other two, and we won't press the bearings in. We'll press the bearings in two of them, but one of them we'll make a beveled pulley out of. We'll put a slight angle on each side. We'll get to that a little later. Alright, I have all three of the rollers ready to go now for the bearings. Have them bored out, have the bearing shoulder in there. Now we're going to take one of these bearings. I've made an arbor to hold it. As I said earlier, we need to put a bevel on this, or a crown. We're going to crown this roller right here. So I've made an arbor. That will hold that in, put a little washer on it. Now that should hold that sufficient. And I've got my compound. Got it compound set at 3 degrees. I found a drawing for one of these rollers. It was metric, but of course the angle doesn't make any difference whether it's metric or imperial. But it worked out to 3 degrees. So what I'm going to do now is mark the center of this roller and get it dried off good. I've measured this roller, and I have my caliper set at half that. So I'm just going very easily That's all I needed. Just a reference mark. So we're going to run the compound up now, cross slide. Until, as we work this in, until the point comes to that center line we just marked. And I'm not going to worry about trying to get a super fine finish turning this by hand, because we're going to put the emery cloth on it after we get it turned with the lathe and to dress it up. Alright, that has this side done. I'm going to turn it around on the arbor and do the same thing to the other side, and then we'll clean it up. Alright, I'm going to unlock the carriage, get it out of the way. Then we're going to take some emery cloth. Tell you what, with that right there, I think I'll just go ahead and put use the chamfering tool on it. And get us a nice rounded off corner edge. And again, one final burnishing with the file. All right, there's our crown roller. Not Crown Royal, but crown roller. I'm going to move the camera around to the press, and we'll install some bearings. I'm over at the press now, and I'm not sure, there's not a whole lot of light, or not as much light over here in this back corner of the shop. So, but hopefully you can see it. I got one on pressed in before I turned the camera on. And of course it works fine. I don't have any dry ice like Mr. Pete used when he was pressing in bearings, but I've had these in the freezer for just a little while. And we're going to set those in there very gently. Well, if the rest of them will work that well, I will be some kind of pleased. That one's rolling fine, and here is our crown. When it was crowned, and I've let it cool off, it got just a little bit warm, putting that surface on there. These are the two rollers that's been in the freezer for a couple of hours, so they act like they're going to slide right in there. Plus the crown roller is just a little warmer than the others. Alright, I'll carry these over there to the workbench and we'll do a quick recap on the rollers. This was my first experience with doing anything that required making bearing seats, and I wasn't really up to speed at all on how much of a shoulder to leave for the bearings. And I want to thank some of the members over on the YouTube Machinist group on Facebook. I posed a question to them as far as what I wanted to do, and asked for some guidance on there on which, how much of a tolerance to leave on here for the press end and so forth. And I got a lot of good responses. I was able to find some literature on this bearing. This bearing size, I believe I said before, is a R8ZZ. And the specs that I found on it matched perfectly with what I had. The only thing I didn't find anywhere on the specs was how much of a interference to leave on the outside. But the viewers or the members there on the Facebook group, the general consensus was approximately 1/1000th per inch bearing diameter. These are 1.125 diameters, so I shot for 1/1000th clearance on that, and that seems to work good. Everything is back to ambient temperature now. Everything's rolling freely. No binding at all. So I'm pleased with the rollers. This is the beveled one. I'm not sure. Excuse me, the crowned one. Not sure that you can see that crown, but there's definitely a crown in the middle. That gives you an idea. I think it turned out rather well. That was the arbor I was using to put the crown on it. And as you recall, this is what we started with, something like this. So we'll move on to the next part of the project. I'm thinking most likely what I'll do is use 1/2-inch bolts for the axles in there. But I will clean off the grade markings and so forth off the end of them. That should be easier than trying to turn the hexes and so forth. I'll think about that a little bit. It is a good fit in there. But we'll move on to the next part of our project. Okay, this is going to conclude part 1 of this video series. The one thing you didn't see in the machining of the rollers was these guides that I have on each side of the tracking roller here. These were added later just to help keep keep the belt on there as I was getting this adjusted. The next part we're going to look at in the next video in this series is the machining of these T-bolts and the nuts that go with them.